When dealing with a three-phase 4-wire transformer feeding a service disconnect panel that supplies multiple buildings, specifically in an outdoor setting with underground PVC conduit runs, adhering to the National Electrical Code, or NEC, is crucial for safety and proper system operation. The NEC mandates specific grounding requirements to ensure that each building has a robust and reliable grounding system. The core question revolves around whether a grounding conductor needs to be run from the transformer to each of the buildings, or if simply running 3 ungrounded conductors, 1 grounded conductor, and bonding the service panel in each building would suffice. The NEC is clear on this requirement. A grounding conductor must be run from the transformer to each building. This is because the NEC requires that a grounding electrode system be installed at each building and that it must be connected to the service panel using a grounding electrode conductor. This grounding electrode conductor serves as the critical link between the building's electrical system and the earth, providing a low impedance path for fault currents to return to the source. Now let's delve into the specific requirements and considerations involved in implementing this grounding system. Firstly, the grounding electrode system at each building must comply with NEC Article 250. This article outlines the various types of grounding electrodes that are permitted, as well as the requirements for their installation. Common grounding electrodes include ground rods, ground rings, metal underground water pipes, and concrete encased electrodes, often referred to as UFA-grams. The choice of grounding electrode will depend on site conditions and local requirements. Secondly, the grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. NEC Table 250.66 provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. It is crucial to consult this table and ensure that the grounding electrode conductor is adequately sized to handle potential fault currents. Thirdly, the grounding electrode conductor must be connected to the service panel in each building in accordance with NEC Section 250.24. This section specifies the methods for connecting the grounding electrode conductor to the service disconnecting means and the grounding bus within the panel. The connection must be made in a manner that ensures a reliable and permanent electrical connection. Fourthly, the NEC permits the grounding electrode conductor to be run in the same trench as the other conductors, including the ungrounded conductors and the grounded conductor. This can simplify the installation process and reduce the amount of trenching required. However, it is essential to ensure that the grounding electrode conductor is properly protected from physical damage during installation and backfilling. Fifthly, in addition to the grounding electrode system at each building, it is also necessary to ensure that the service panel in each building is properly bonded. Bonding refers to the process of connecting all non-current carrying metal parts of the electrical system together to create a low impedance path for fault currents. This includes bonding the service panel, enclosure, metal conduit, and other metal components. Sixthly, the NEC requires that the grounded conductor, often referred to as the neutral conductor, be connected to the grounding electrode system at the service disconnecting means in each building. This connection is typically made at the neutral bus within the service panel. The purpose of this connection is to provide a return path for neutral currents and to help stabilize the voltage on the neutral conductor. Seventhly, it is important to note that the NEC prohibits the use of the earth as the sole equipment grounding conductor. This means that you cannot rely solely on ground rods or other grounding electrodes to provide a path for fault currents to return to the source. Instead, you must run a separate equipment grounding conductor along with the circuit conductors to each building. The equipment grounding conductor is typically a green or bare copper wire that is connected to the grounding bus in the service panel and to the metal enclosures of electrical equipment. Eighthly, when dealing with multiple buildings fed from a single transformer, it is also important to consider the requirements for overcurrent protection. The NEC requires that each building be provided with overcurrent protection at the service disconnecting means. This overcurrent protection can be in the form of circuit breakers or fuses. The size of the overcurrent protection must be selected based on the ampacity of the service entrance conductors and the load served by the building. Ninthly, the 200-foot distance between the transformer and the buildings is a critical factor when considering voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors running from the transformer to the buildings. Tenthly, the fact that the buildings each supply 10 apartments adds another layer of complexity to the electrical design. The NEC contains specific requirements for the electrical systems in multi-family dwellings, including requirements for lighting, receptacle outlets, and appliance circuits. It is essential to consult these requirements to ensure that the electrical systems in the apartments are safe and compliant. 11thly, the use of underground PVC conduit for the conductors running between the transformer and the buildings is a common practice. PVC conduit is a durable and corrosion-resistant material that provides excellent protection for the conductors. However, it is important to ensure that the PVC conduit is properly installed and supported to prevent damage. The NEC contains specific requirements for the installation of PVC conduit, including requirements for burial depth, support spacing, and expansion fittings. 12thly, the outdoor setting of the transformer and service disconnect panel requires additional considerations for weather protection. The equipment must be suitable for outdoor use and protected from rain, snow, and other environmental factors. Enclosures must be rated for the appropriate environment, such as NEMA 3R or NEMA 4. 13thly, when installing the grounding electrode system at each building, it is important to ensure that the grounding electrodes are properly installed and make good contact with the earth. Ground rods should be driven into the ground to a depth of at least 8 feet, and ground rings should be buried at a depth of at least 2.5 feet. The soil around the grounding electrodes should be moist and free of debris. 14thly, regular inspections and testing of the grounding system are essential to ensure that it is functioning properly. Brand resistance testing can be used to measure the resistance of the grounding electrode system. A low resistance reading indicates that the grounding system is effective. 15thly, it's crucial to document the grounding system thoroughly. This includes keeping records of the grounding electrode type, size, location, and test results. Proper documentation can be invaluable for future maintenance and troubleshooting. 16thly, consider using exothermic welding, also known as a CAD weld, for grounding connections. This method creates a permanent molecular bond that is highly resistant to corrosion and loosening, ensuring a reliable connection for the life of the system. 17thly, be aware of local amendments to the NEC. Many jurisdictions adopt the NEC but may also have their own local amendments that modify or add to the code requirement. It's essential to check with the local electrical inspector to determine if any local amendments apply to your project. 18thly, ensure that all electrical work is performed by qualified and licensed electricians. Working with electricity can be dangerous, and it's important to have the knowledge and skills to perform the work safely and correctly. 19thly, consider the potential for lightning strikes. If the buildings are located in an area with a high incidence of lightning strikes, it may be necessary to install a lightning protection system. A lightning protection system can help to protect the buildings and their contents from damage caused by lightning strikes. 20thly, if the transformer is located near other utilities such as gas or water lines, it's important to maintain proper clearances. The NEC specifies minimum clearances between electrical equipment and other utilities to prevent accidental contact or interference. 21st, when running conductors underground, be sure to use the correct type of wire. Underground feeder or off cable is specifically designed for direct burial applications. It is moisture resistant and can withstand the rigors of being buried underground. 22nd, be mindful of the backfill material used when burying the conduit. Avoid using sharp rocks or other debris that could damage the conduit or conductors. Instead, use a clean, granular material such as sand or gravel. 23rd, when making connections in the service panel, be sure to use the correct type of connectors. Use connectors that are specifically designed for the type of wire being used and that are properly sized for the conductor. 24th, double check all connections to ensure that they are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. 25th, label all circuits clearly. This will make it easier to identify circuits in the future and will help to prevent accidental disconnections. 26th, keep the service panel clean and free of debris. Dust, dirt, and other contaminants can accumulate in the panel and cause problems. 27th, consider using a surge protective device or SPD to protect the electrical equipment in the buildings from voltage surges. Voltage surges can damage sensitive electronic equipment and can also cause fires. 28th, when working with electrical equipment, always follow lockout/tagout procedures. This involves disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent accidental re-energization. 29th, be aware of the potential for arc flash. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit in the air. Arc flash can cause severe burns and even death. 30th, always wear appropriate personal protective equipment, or PPE, when working with electrical equipment. This includes safety glasses, gloves, and arc-rated clothing. 31st, if you are not sure how to perform a task safely, stop and ask for help. It's always better to be safe than sorry. 32nd, remember that the NEC is a minimum standard. You may need to exceed the requirements of the NEC to ensure the safety and reliability of the electrical system. 33rd, stay up to date on the latest changes to the NEC. The NEC is updated every 3 years, and it's important to be aware of the latest changes to ensure that your work is compliant. In conclusion, running a grounding conductor from the transformer to each building is a mandatory requirement according to the NEC. This ensures a safe and effective grounding system, which is critical for protecting people and property from electrical hazards. Adhering to all relevant NEC guidelines and best practices is essential for a compliant and reliable electrical installation.